Hi, I'm Dale from Nude's Closet, and it's really kind of cool, literally a little cool. In Alabama, it's in the low 30s, and you'll see on the trees behind me there's something called snow. For most of the United States, you deal with that all the time. But here in the state of Alabama, this is a pretty rare sight. And one of the interesting things about this particular situation is that the temperature is actually above freezing, and yet the snow is still on the trees. And if you'll take a look, there's no snow on the ground. And so what is it that makes this possible? What it makes that fact that the temperature is above freezing and we still have snow on the trees and no snow on the ground? Well, one of the biggest things that you find is that most of the time we don't differentiate between temperature and heat. Temperature is the average kinetic energy of molecules, but heat is the total amount. And so if we can define temperature and heat, we may be able to explain this odd thing we see behind me. So when we're talking about temperature and we're talking about heat, we're actually talking about two different things, although they are related. Like you have brothers. Brothers are two different things, but they come from the same family, so there are relationships that make this work. And one of the things we have with water is water contains a tremendous amount of heat. And the reason that it has a tremendous amount of heat is because it has a tremendous amount of mass. And it has something called a specific heat, which is 1 calorie per gram for every degree Celsius that it has, right? So if you have 20 degrees Celsius water, you're going to have more heat than 2 degrees Celsius water. But the key is the mass. The specific heat of air is a lot different. It actually doesn't contain a tremendous amount of heat. And so when the temperature drops, the amount of heat is not that great. So on the trees, you will see ice and you will see a little bit of snow, and that's because the air underneath it doesn't contain a lot of heat. So even though it's 34 degrees Fahrenheit or about 2 degrees Celsius, underneath, not a lot of heat. And it's heat that melts the ice and the snow. If you were to take water at that temperature and put it on top of the water, it would melt a whole lot faster because there's more heat that can be pulled from the water. Now, let's reverse this. Imagine that I was to jump in this really cold creek. I would immediately feel very, very cold. And the reason is I am a heat producer. And because I'm a heat producer, that is going to pull heat out of me. If I stand in a windy place and the wind blows and blows cold air across my body, it's pulling the heat away. So even though the temperature of the air is a particular amount, how that air passes by matters. The material itself, whether it is water, whether it is air, whether it is steel, they all have different specific heats. And in the process of working with that, you end up with different things that happen. For example, if it stayed below freezing, this would still flow because the energy from it flowing would keep it from freezing. But if it stayed cold long enough and the heat inside this river came out into the air and all of a sudden that water doesn't have enough heat to stay a liquid, it would start freezing. But where would it freeze first? It would freeze in the areas that aren't moving. So, temperature, heat, Alabama, really cold, kind of strange, but at Newton's Closet, that's what we do. We open the closet, whatever falls onto the floor, we pick up, we look at, and hopefully you've enjoyed this segment. Stay tuned for more things like this. Newton's Closet al@gmail.com. If you have any questions, I'm Dale. We'll see you next time.